Hello everyone, welcome back to my channel. My name is Desha Korwal and this is my second video, and today we're going to cover the topic of VLANs. Today's agenda, we're going to give an introduction to LANs. I'm going to also provide an example of LANs. Then I'm going to introduce VLANs, also give an example of VLANs, and then we'll see how to configure VLANs. So before I get into VLANs, we need to understand what a LAN is first. A LAN stands for local area network. LAN, in the sense, a LAN is a group of devices in a single location, which could be an office, your personal home office, or your work office. A more specific definition regarding networking is that a LAN is a single broadcast domain that includes a group of devices that will receive a broadcast frame with the destination MAC of all Fs. Meaning when we, let's say in the last video where we did the ARP request and ARP reply, a broadcast domain would be a group of devices that will receive that ARP request, which is all Fs. That is a LAN. So let's give an example of what a LAN is and how it looks in a general network. So here I made a topology of routers, switches, and PCs. And from the last video, let's recall what a broadcast frame would do in this topology. Let's say we had PC2, sorry, second, we had a PC2 send out an ARP request. Um, or an ARP request, which is a destination of all Fs, will only stay in a network and it will not go beyond a specific network. And that network would practically end a router. So when we say, hey, what is a LAN? We will say that this is a LAN because when we send out the ARP request or any packet with a MAC address of all Fs, that packet will first go from PC2 to switch, and that switch will forward that packet it will forward the packet out to PC3 and the router. Now PC3 will see, well, hey, this packet is now for me. It will drop the packet. A router will also receive the packet, but because routers work on a layer 3 basis, it will essentially drop the packet if the packet is not meant for itself. A router will never forward a broadcast frame. Knowing that this is one LAN, what else LAN can we see here? We see that there is another LAN here, this LAN. We see, well, this is LAN, and we also see that this would be another LAN. Now, what about this section here? Would this be a LAN? Technically, it is a LAN because they all because they still have a connection in between. And potentially, in an actual environment, there could be more devices between these routers. So yeah, this is also another LAN. So technically, in this topology, we have 4 LANs. Coming back to our presentation. Actually, before we go back to the presentation, I want to elaborate more on the LANs. So here I have another topology, a working topology where we have 3 different departments. We have engineering, sales, and HR. They're all a part of the same network, 192.168.1.0/24. And I want to just simulate how this works. So first, I think we should do this first. We should clear MAC address table, and let's also clear the MAC address table from the PC6. Actually, let's just call that right now. HT. Let's go back to simulation mode, and let's ping from PC6 to PC9. So ping 192.168.1.3. PC9 is 1.3 right now. So if you send a ping, again, we have the actual ARP request. We have an Ether frame from 431C to all Fs, and it's an ARP packet, as you can see, source IP, destination IP, and it will send it to the switch. So it receives the ARP packet, and it will see, well, hey, this is an ARP request, and the destination is all Fs, and so I'm going to forward this out of all ports except the ingress port. So let's see, it sent it out of all port. And then everyone, as you can see, is denying the packet because they do not, the source or destination IP mentioned in the packet does not match their own IP. So they're all denying the packet except PC9 that is accepting the IP address and accepting the ARP request. And now it's going to reply back to PC6 and goes back to PC6 and it gets checked. And now PC6 will be able to fully ping PC9. So what we just witnessed now here is that, hey, we just witnessed a broadcast domain. PC6 sent a broadcast frame to switch 3, and switch 3 just broadcasted that frame to everyone in that LAN. This could cause a lot of issues, specifically to performance. When there's a lot of broadcast traffic like this, it could reduce the network performance. And not just that, it could also affect security. Let's say we had some servers in engineering here that we did not want to have access to by other departments. Say sales did not we didn't want to give sales that permission to access the servers. Well, with this broadcast, they could still access it. There's still ways for it to get through, which is another big part of LANs. So the one thing that we can do to prevent access or reduce broadcast storms is we could start by segmenting the network entirely. So right now we have 192.168.1.0/24. I'm going to do some segmenting and I'm going to come back in a second. So I've added the IP addresses here and I've segmented the network based on layer 3. Another thing that you will notice is that I'm using 3 different connections from switch to router. That is there because the router would need an IP address in all these 3 IPs. There's an easier way to do this, and that will be covered in a different topic, most likely in the next video. But for now, we're going to go with this. But again, this is still a broadcast domain. This is still a LAN, even though we have segmented the network based on layer 3 IPs. LANs, LAN works on based on layer 2. So even if PC6 was to ping PC9 again, you will see that, hey, this is again a broadcast domain. So first, let's just do this. I did some confirmation just now, so let me just clear MAC address. MAC address is off of everything. Clear MAC address table. Yeah, I was going to clear MAC address table over here. ARP-D. I'm also going to clear ARP-D. I'm also going to clear my table here, ARP-D. Another thing that we should do is we should also clear here, exit, clear, MAC. Oh, it doesn't have that. Oh well, Wait, sorry, doing the wrong mode. Clear MAC address table. And let's see how the packet would transverse this time. So simulation, I'm going to go to PC6 and I'm going to type ping 192.168.1.129. Notice the IPs is different because this is again in a different network now. So start the ping. We have ping again, and as you can see, we have another ARP request because we are forcing it to do an ARP. Now you would see, instead of sending it straight to PC9 to 1.129, it is sending it to it is sending the packet to 192.168.1.62, which is the IP address of the router port. Sending the packet, sending the ARP request to the router because the destination is in a different network. So let's see how that goes. PC2 or switch receives it, and switch, what does switch do? Knowing it's a broadcast packet, it will forward it out of all ports. Again, regardless of what port the packet is or what IP is supposed to go on, it will send the packet out to all ports. As you can see, again, this is still a LAN and it's still denying the packet because it does not do broadcast packets. It does not take broadcast packets. But as you can see, broadcast sends a broadcast packet back. It's a unicast frame, and it's an ARP reply. Sends it back, and then PC now finally sends the packet again. It's a unicast packet. Well, let's see what the frames were. And scan, receives it. It was unreachable. Well, again, this is another part of the thing. You can see that it broadcasted the packet to everyone while it's still a LAN. So let's see how to configure a VLAN now, or actually before that, let's see what a VLAN is. So we looked at what a LAN is. Now let's look at what a VLAN is. A VLAN, again, stands for Virtual Local Area Network. A VLAN is a logical separation of a LAN based on layer 2 MAC addresses. When we saw the example in Packet Tracer, we saw that the switch was still broadcasting those packets. A switch will never forward traffic between different VLANs. So let's say if we had PC6 in VLAN 10 and PC7, PC6, PC10 in VLAN 10, 7 and 8 in VLAN 20, and PC9 and 11 VLAN 30. All broadcast frames sent by PC6 will remain in VLAN 10, which would cover PC6, PC10, the switch, and the router port. So let's configure VLAN and then also see an example of how VLANs work. So let's see how to first configure a VLAN. So I'm here on the switch. Note VLANs and everything to do with VLANs is configured on a switch first. So as you can see, we are on the VLAN here. To create VLANs, it's simple command VLAN 10. I'm going to name VLAN 10 as engineering, just eng, and I'm going to exit it and it'll create the VLAN. We also going to create VLAN 20 for, actually this is supposed to be VLAN 20, that's supposed to be VLAN 30. So VLAN 20 for HR, VLAN 20 name HR, and VLAN 30 for sales. And to check the VLANs that you have created, we can do show VLAN brief. And as you can see, we have 3 VLANs here, 10, 20, and 30. But also you will notice that we do not have any ports assigned to them. How do we do that? Well, we can go into the port itself, or we could do an int, or we could do a range of ports. So let's do a range of ports first. Int range F01 to 2, that is PC6 and PC10. We do switch port access VLAN 10 and no should. Now this will, if you do show VLAN brief again, you will see that we have two ports under engineering, which is FO1 and FO2, and as you can see, they're converging right now. So let's go ahead and do that for the other two ports as well. Int range F03 to 4, switch port access VLAN 20, no shut, and int range F05 to 6, switch port access VLAN 30, no shut. So if we do show VLAN brief, we can see that we have two ports connected to each of them. What we should also do is that we should also add the router ports on switch 3 to these three interfaces, or to these three VLANs. So let's go ahead and do that right now. Int VLAN 10 is G01, switch port access VLAN 10, shut, int G02, switch port access VLAN 20, no shut, and int F024, switch port X VLAN 30, no shut. And if you do a do show VLAN brief again, you can see that the three ports have been added to the specific VLANs. Yeah, so this is how you segment it. What is that? So now we have separated all of the ports, all of the PCs, all of the departments into their own specific VLANs. So let's go ahead and confirm if that works, if our configuration and if our VLANs are properly working or not. So simulation, before we go to simulation again, let's just clear all of MAC addresses. So clear MAC address table. I'm also going to do clear MAC address table here. Clear MAC address table. I'm also going to clear, actually I'm going to ping 7 here. ARP-D, and also do ARP-D here. -D. So let's do a simulation again. For PC6, let's try pinging PC7. So ping 192.168. Well, first, actually, before we ping that, let's just see where the broadcast storm is, or sorry, not the broadcast storm, where the broadcast domain is. So let's ping the broadcast network, or the broadcast IP of engineering department, so which is 192.168.1.63, and see what replies we get. So we have ping here ready to travel to the network. Let's open the packet up and let's see. Again, 192.168.1.1, destination all IPs. Layer 2, again, we see the MAC address and we see the all Fs ready to send it over. Switch receives it. It will look at the packet. It will see that it was received. Matches the receipt percent of the MAC address. And another frame. And yes, as you can see, it only sends it to PC10 and the router. Again, this is an R packet 102 and just 101. Back to PC6. And that's how we created proper segmentation. We can also try it from here if we want to just ping. Let's see if we should ping 192.168.1.127. Yeah, if you ping 127, again it will create the same packet and it will stay within VLAN 20. Receive it. You can see stays within the thing. Send it out only to those PCs in that VLAN. Now let's try pinging from PC6 to PC7. Again, I'm going to clear MAC address table again because it has taken the addresses in. ARP-D, ARP, and ICMP. Let's clear the table from here. ARP-D. Wow. Okay, so let's ping 192.168.1.66, and we see, well, first of all, let's see the ARP packet. Well, because the PC6 sees that, hey, 1.66 is in a different network entirely, I'm going to send this packet to my router. And that's why it's destined for 62, because it does not know the MAC address of router for its own router or for its own default gateway. So it's going to first resolve the packet. It is, again, it's a broadcast packet, so PC10 will also receive the packet. Router receives it and sends it back, saying, hey, this is my MAC address, and now it will make the packet, will send out the traffic to switch. Switch will send it out to router. Router sees, hey, actually let's see the packet. Router sees, hey, source is 192.168.1.1, destination is 1.66. Sees, okay, I have a network in that I have an interface in that network, but I don't know the destination MAC of that PC. So it will send out an ARP request for PC7. As you can see now, we send out an ARP request. It will again get broadcasted into PC7 and PC8. And there we go. PC8 will deny it. Oh, sorry, PC7 will deny we ping PC8. We didn't ping PC7. It will get the back. It will get the ARP reply, and now it will send again. And this time, it will be sending the ping to PC8. You see, let's just see, and it gets the packet. It's going to send it back as an echo reply, a CMP echo reply, and we can see that happening here. It timed out first because there's a TTL on the packet, which is usually about, yeah, as you can see, 128. It also got denied. The router 2 denied the packet first. And see, we got a reply. So as you can see, we got the VLANs working properly. And this is now a properly segmented network. Another topic that I want to cover, which I'm going to cover in the next video, is router on a stick. Right now, we are using 3 links in here, which is not very efficient because it's now blocking 3 ports. There is another method that we can use, which is called router on a stick. We are going to implement that in my next video. We're going to continue on VLANs. I'm also going to explain a new protocol, which is VTP. It's a Cisco proprietary protocol. With that, we're also going to cover router on a stick. So thank you guys for watching. I know there were some hiccups in this video. Please look past them. I tried my best here. Thank you for watching. I'll see you next time.